Hey everyone, and welcome back to another edition of The Explainer. I'm so thrilled you're joining me today because honestly, we've got a fantastic and incredibly practical walkthrough queued up. We're going to take some familiar, super powerful tools and combine them to effortlessly build a semantic search engine. And it's always fun to have a theme, right? So we are going to build a holiday movie recommender. Our big goal for today? We want to walk away with a fully functional RAG application. That's retrieval-augmented generation, using a Django MongoDB backend. So grab your coffee and let's dive right into it. Now, you might be wondering, how on earth do you build an AI app in just 30 minutes? There's this persistent myth out there that adding artificial intelligence to your web apps requires, months of deep research, crazy complex math, and massive computational overhead. But today, we are completely busting that myth. We're going to treat this explainer exactly like a cooking show. Instead of getting bogged down in all the heavy theory, we're taking a super quick recipe-like approach. Because by utilizing modern frameworks and managed services, wiring up a state-of-the-art AI app is literally faster than baking a batch of holiday cookies. So, here is our menu for today. 1. The RAG app ingredients. 2. Prepping the Django backend. 3. Generating AI vector embeddings. 4. Building Atlas vector search. And finally, 5. Querying our data with LangChain. All right, let's kick things off with step 1. Gathering our RAG app ingredients. The core concept we're building around today is RAG. Now, if you aren't familiar, RAG stands for retrieval-augmented generation. Basically, instead of just asking an AI a question and crossing your fingers hoping it knows the answer from its general training, a RAG architecture fetches specific, highly relevant data from your own database first. It then feeds that context straight to the AI model before it generates a response. It's like giving the AI an open book test. For our project today, our context is a JSON dataset containing 20 classic holiday movies. Think classics like It's a Wonderful Life. And it includes all their plots, runtimes, genres, and awards. Here are the primary tools we'll be pulling from our tech pantry. First up is the newly minted Django MongoDB backend. This is a real game changer because it natively uses PyMongo to connect Django directly to MongoDB. Next, we have Voyage AI, which is the platform that's going to handle our semantic models and create our embeddings. Then there's LangChain, our orchestration framework that completely simplifies data ingestion and coordinates the whole shebang. We'll be hosting our data on a MongoDB Atlas cluster. And by the way, the free tier works perfectly for this. And finally, you'll just need Python 3.10 or later and your favorite IDE. We're assuming VS Code for this particular recipe. Looking at our precise measurements, you'll want to drop these specific package versions straight into your requirements file. We need python.inf to manage our environment variables, plus Voyage AI, LangChain Voyage AI, and LangChain MongoDB. You'll also want to make sure you create a .in file right in your root directory to securely hold your MongoDB connection string and your Voyage AI API key. Seriously, whatever you do not hardcode those. Moving right along to step 2, prepping the Django backend. This step brilliantly illustrates exactly why using MongoDB with Django is so incredibly exciting right now. Look, in a standard SQL-based Django app, handling things like a list of genres or, say, a nested dictionary of awards, it usually requires complex relations or setting up extra tables. It's a headache. But with the Django MongoDB backend, we can map perfectly to our JSON dataset using specific MongoDB backend fields. We use embedded model field to gracefully nest our awards data directly inside the movie document and array field to hold our list of genres. It just makes modeling complex data so clean and simple. All right, on to step 3, generating AI vector embeddings. Before we run any scripts, let's make sure we actually understand what we're generating here. What exactly is a vector embedding? Well, simply put, it's a numerical representation of text that captures its underlying meaning and context. And why does this matter? Imagine you're searching for a heartwarming family film about angels. If you only use exact keyword matching, a movie plot that says an angel is sent from heaven to help a frustrated businessman might barely even rank if it misses the exact words heartwarming or family. Vector embeddings fix that. They allow the computer to understand that those concepts are semantically similar, even if the words are completely different. To create these embeddings, we're going to write a really quick Python script called plot_embedding.chi. The logic flows basically like this. First, we load up our holiday movies JSON file. Second, we extract just the plot fields from the data, because that's the text we really want the AI to understand. Third, we pass that list of plots over to Voyage AI using their Voyage 3 Lite model, and we specify document as the input type. Finally, we take all those freshly generated numbers, map them to a brand new field called embedding for each movie, and save the whole thing to a new file called embeddings_holiday_movies.json. Time for step 4, building Atlas vector search. Now we need to actually execute the upload, and we do that using a script called json_upload.py. We're using PyMongo here to connect to our MongoDB Atlas cluster via that handy connection string we saved earlier in our .env file. We point it straight to a database called festive-flixdb and a collection called holiday_movies_collection. The script is smart. It safely clears out any existing data in that collection with a delete_many command. And then it uses insert_many to push our newly generated JSON file, complete with all those complex vector embeddings, right into the cloud database. Okay, pause for a second because this is absolutely crucial. 512. I want you to remember this number. Once our data is sitting securely in MongoDB Atlas, we have to create a vector search index via the Atlas UI. And when you configure that index, you must specify the exact number of dimensions your chosen AI model outputs. Because we used Voyage AI's Voyage 3 Lite model, that number is exactly 512. Putting in the wrong number here is such a common bug, and it will completely break your search, so always check your model's documentation for sure. To get this set up, here's the exact click path you'll follow in the MongoDB Atlas UI to correctly index our movie data for semantic search. You're going to go to the Search and Vector Search tab, click Create Search Index, and then select Vector Search. From there, choose your festive_flixdb database and your holiday movies collection. For the path, just type in embedding, since, that's what we named the field in our JSON. Enter 512 for the dimensions, choose cosine for the similarity method, hit create, and boom, your database is officially semantically searchable. Finally, step 5, querying our data with LangChain. We're going to create one last script called LangChain_integration.py. This is where LangChain basically wraps all our hard work up like a perfect little holiday present. First, we instantiate MongoDB Atlas vector search and point it to our cluster. When a user asks the question, LangChain automatically steps in, takes that text, and embeds it using Voyage AI. It's essentially translating the user's human words into the exact same mathematical language as our database. Then, it executes a similarity search against our Atlas index. We set k equals 3 to tell it we want the top 3 closest matches. And finally, it retrieves those matching movie plots along with their metadata. Let's test it out, shall we? We're going to pass the exact query Santa Claus into our script to test the database's shiny new capabilities. Keep in mind, we aren't just doing a basic text match for the word Santa here. We are looking for the movies whose plots mathematically resonate the most with the actual concept of Santa Claus. And just like that, the terminal lights up with the top 3 results. Our script easily extracts the metadata from those closest matches, pulling out the title, the runtime, the genres, and even those nested awards we modeled earlier. To finish off our web app, we simply take that LangChain query logic, place it inside a standard Django views.py function, and pass that extracted metadata right over to a simple Django HTML template. And there you go. The raw terminal data is beautifully and elegantly rendered in the browser for the user to see. And there you have it, folks. By combining the native document handling power of the Django MongoDB backend, the semantic intelligence of Voyage AI, the orchestration of LangChain, and the indexing capabilities of Atlas Vector Search, we literally built a fully functional RAG app and holiday movie recommender in just 30 minutes. The efficiency of this modern tech stack is absolutely staggering when you think about it. So I want to leave you with this final provocative thought. Now that you have the recipe, what will you build in your next 30 minutes? Thanks so much for joining me on this explainer. Keep experimenting out there, and I will see you in the next one.